Hello, this next video will show you how to create a 9-node model that is related to CD4 T-cell differentiation. The model we want to create is this one right here. 3 phenotypes, Th17, Treg, and also Th1. Depending on the cytokines you initialize the model will differentiate into one phenotype or another. Let's take a look at the differentiation dogma. For example, when we have IL-6 and we have TGF-beta, these two cytokines together will activate ROR gamma T. This ROR gamma T, as we've seen in the previous model, will activate production of IL-17. In this picture, naive CD4 T cell with IL-6 and TGF-beta differentiates into a Th17 cell that expresses the transcription factor ROR gamma T and produces a cytokine named IL-17. In contrast, this next phenotype, Treg, only with TGF-beta in the system, only with TGF-beta, will activate FOXP3. FOXP3 will at the same time activate the production of anti-inflammatory cytokines, such as here we put IL-10, it can be TGF-beta. Again, a naive T cell with TGF-beta differentiates into a Treg, expresses the transcription factor FOXP3, and secretes anti-inflammatory molecules or cytokines such as TGF-beta or IL-10. The third phenotype is Th1. Now Th1 is an independent pathway here in this model. In this case, it gets differentiated with IL-12, produces the transcription factor Tbet, and secretes interferon gamma. A naive CD4 T cell, when encounters IL-12, right here, differentiates this naive CD4 T cell into a Th1, expresses the transcription factor Tbet, and produces interferon gamma. Now, with the previous model, we just created this one, the Th17. Now we're adding another phenotype, Treg, and also another one, which is Th1. So it's a 3 phenotype network. Now, this video will not show you how to create this model into Copasi. This is an exercise for you now. What we will show you is some tips that you can use that we haven't shown you before that will accelerate the process of the creation of this model. Please go to the other video if you have any questions, but let me show you a little few tips on this model, because there are some things that are different from the previous model, which was a very simplistic model. Alright, let me show you. If we open CellDesigner, I'll create a new one. I'm not even going to put a title. Let's press, or we can put example, 9-node for example, press OK. Alright, first let me show you what would we do in this model. We'll create a square here, one compartment, and we will create, probably we will create 2 species. We'll do a species A, okay, and we'll also do a species B. And the idea is that these 2 species together will produce C. So before we worked with state transitions, but in this case IL-6 together, and you see this black dot in here, together with TGF-beta, together they activate ROR gamma T. So how do we represent that in CellDesigner? Well, state transition is only one example of things we can do. There are other associations. There are complex associations or simply an heterodimer association. So if we click in this one, we can select A, we can select B, and after selecting C, we see how this specific relationship is built. Now let me show you something else. Let's create something like D, for example, okay? And in this case, we'll do a transition from B to D. Now let me show you one thing. See this ROR and this FOXP3, how they have something else in here? ROR gamma T inhibits FOXP3 activation. And FOXP3 at the same time inhibits the expression of RORγt. So how do we do this in CellDesigner? There's another part here in the menu that is used for catalysis or activations, but also inhibitions. So if we click inhibitions, we can go from a node to a reaction. Now we're not going to the other node, we're going to the reaction. Please note that. Do you see these anchor points here? We can create these anchor points by just right-clicking and selecting Add Anchor Point. And we can create as many as we want. This is just a design detail, and you can do this as you like. Now let me show you one last item here. Do you see how we've drawn here the degradation of different species? How do we do this in CellDesigner? If you check here, see this degraded node in here? This represents a node, but the notation is just a degraded notation. And we can just apply a state transition from a protein to the degraded node of this particular species. Alright, well, with this you should be able to construct this node. Let us know if you have any questions. We'll be really happy to help you guys out.